Alright, on this video, the instructions say write the following numbers as fractions. It's already a fraction. Simplify it if possible. If the number cannot be written as a fraction, write that it is not possible. Okay, I'm going to do several examples with you here. Number 1, okay? This number pi, okay? Pi is 3.14, and we know it's like a dot number. It goes on, non-terminating, non-repeating decimal number. Okay, anything with a pi in the number, right? This symbol pi, you cannot write it as a fraction. Okay, so right, we are rewriting as fractions. Okay, and if it cannot be written as a fraction, write that it's not possible. Okay, so if it has a pi in it, okay, you cannot write it as a fraction. Not possible. Okay. Alright, number 2. Alright, this is negative, it's just a negative 62. Okay. It's an integer. Any integer or any whole number, I can rewrite it as a fraction, right, by putting it over 1. Negative 62 over 1. Right? Oh, there's your fraction, negative 62 over 1. Okay. Number 3, it is a repeating decimal. Okay, unlike pi, where you had a decimal where it was not repeating, this one is a repeating decimal. Okay, so you have this, 73 is your whole number. And you know, repeating decimals you can write a fraction for. Okay, so what's that rhyme, right? Decimal repeating line, the denominator has 9. This decimal has a repeating line, the denominator is going to have 9. How many 9s is it going to have? It's 3 repeating decimal numbers, so that means it's going to have 3 9s in it. Okay, and the numerator is just going to be 948. 948. Okay, decimal repeating line, the denominator is 9. It's going to have a fraction. Okay. Alright, number 4. For number 4, square root of 50. If you look at your perfect squares in your notebook, that page where we put perfect squares, square root of 50 is not on that list. This is an imperfect square. Okay, it's an imperfect square. That means it's going to have a dot decimal number. It's going to be non-terminating, non-repeating. Okay, the decimal numbers will not be repeating. Okay, and it's also non-terminating. Imperfect square numbers are like pi. They're non-terminating, non-repeating. Right? These imperfect squares. Okay, not on our perfect squares notes page with the flaps. Okay, so this again, this is not possible. Okay, I want to compare that to number 16. I'm going to jump to number 16 here. That's another one I want to do. Alright, so number 4 was not possible. Imperfect square. Okay, let's look at number 16. In your notebook, on our perfect squares page with the flaps, square root of 100 is on that page. Square root of 100 is a perfect square. If you take the square root of 100, it's 10. Let's rewrite 10 as a fraction. 10 is the same as 10 over 1. Okay, so there's your fraction. Okay, perfect squares, you can rewrite it as a fraction. Alright, so we did 16. Let's jump back to up here. Let's look at number 5. Alright, so for number 5, it's already written as a fraction. Certainly it can be written as a fraction. It's already written as a fraction. Okay? Alright, so we can simplify this. Okay? 34 and 4, common factor is 2. We can divide 2 into both. Okay? So it says if it's already a fraction, simplify. Alright, so let's simplify. So we're going to divide both by 2. Okay, so we're going to divide the Denominator by 2, and we're going to divide the numerator by 2 and the denominator by 2. 34 divided by 2 is 17. 4 divided by 2 is 2. Okay, so it's already written as a fraction. We know it can be written as a fraction. We're just going to simplify it here. Okay, look at number 7. I'm not going to do 7, but 7 has a pi in it, right? Just like number 1 that we were talking about. Alright, let's go ahead and look at number 8. Decimal repeating line. Doesn't have a line on it, but it's repeating. I could write it with a repeating line, right? So this would be with a repeating line. This would be 2.18 with a line over it. Okay, decimal repeating line. The denominator has 9. If it has a denominator, that means it can be written as a fraction. The whole number is 2. Okay. 2 numbers are repeating, the 1 and the 8. That means there's going to be 2 9s in the denominator, 99. The numerator is just going to be 18. Okay. Number 9. 8 over 4. It's already written as a fraction. This can be written as a fraction. We're going to just go ahead and simplify it. Hey, this just is 8 divided by 4. 8 divided by 4 is 2. Let's go ahead and simplify it. 8 divided by 4 is 2. 2 can also be written as 2 over 1, right? 8 over 4 is the same as 2 is the same as 2 over 1, right? 2 over 1, 8 over 4 are the same thing. Okay, we're just going to simplify that fraction. Okay, all right. Number 11. Okay, so in number 11, you have a radical sign, a square root sign. The numerator and denominator are both perfect squares. If you look on your notes, our perfect squares page with the flaps, 25 is on there, 36 is on there. These are both perfect squares. Okay? So, since they're both perfect squares, we're going to take the square root of both of them, and it'll lose the square root sign. Okay? Once we take the square root, we lose the square root sign. Square root of 25 is 5. Square root of 36 is 6. Okay? There is square root of 25 over 36 written as a fraction. Okay? So 11 and 13 are very similar. Check to see on 13 if 1 and 16 are perfect squares. Okay? Alright, number 14. Alright, number 14 is similar to number 4 and 16. Only thing there's a negative on here, okay? Is square root of 81, is it a perfect square? It is. Okay, you can rewrite it as a fraction, just like number 16. Okay, just remember to stick a negative on there. Let's do another one. Alright, so we just did 11. Let's compare 11 to number 19. Okay, so number 19. Alright, number 11. Both of them were perfect squares. We took the square roots of both. In number 19, okay, let's look at in our notes with the perfect squares, right? Those flaps. 9 is on that page. 9 is a perfect square. Square root of 40 is not. Square root of 40, we have a square root sign and we have an imperfect square. Okay, since we have an imperfect square, we're going to have a non-terminating, non-repeating decimal number. We're going to have a non-repeating decimal number that goes on infinitely. It's going to have 3 dots with no repeating decimal numbers. Okay, so this one, since it has an imperfect square, we cannot write a fraction out of it. Okay, so this one is not possible. Okay. Alright. And then I think the only other one I see on here is this one, number 18. 9 1/3. Okay, so 9 1/3. Well, I think it's already simplified, right? Or I think it is already simplified, 1/3. and it's already written as a fraction. A mixed number is a fraction, 9 1/3. Okay, there's our fraction for it. And I think that pretty much covers anything else that is on this page. Okay, all right.